right, welcome back, everybody. Sorry, ladies on the road. I just had to restart because my thing wasn't recording any noise. So there's like 5 minutes of discussion that I had to restart, but I'm not going to go through it all again. Okay, we are starting today. We're continuing 4.4, and we're going to finish it. And our first example is let's use some reference angles. Now, I want to just be completely honest. I don't know that if you were to give me this following problem and the direction said evaluate, I don't know that reference angles are going to be my first thought. Right? Like there's a bunch of ways to do these. We're just looking at each way. Here's how we apply this. And there's a bunch of different flavors, and choose whichever one you like. So with that in mind, I want us to find, using reference angles specifically, the sine of 5 pi thirds. Okay. Now, I could, and I would, realistically, if I were to try to find this, I would just go and look at my unit circle, right? Like that's how we would do it if I had a unit circle in front of me. Pi thirds shows up, 6 pi thirds is 2 pi. I know that this is on the unit circle. But we're not going to do it using the unit circle. We're going to think our way through it a different way because there's times where we get stuff that's not on the unit circle where it's valuable to do this. So the first thing we need is we need to find theta prime and note the quadrant, which if we're going to find theta prime, we have to know the quadrant anyway. So 5 pi thirds, what quadrant? 4. And just so we can see it, in my head, I'm already thinking, if this was a version of it that you liked, if I'm at 0, right? If I go, if I'm going by over 3, here is 3 pi thirds, here's 4.5 pi thirds, and here's 6 pi thirds. Like, I'm just doing that same thing where I cut it into fourths. I know that 5 over 3 is bigger than, what was the number? I already forgot it. Did I just get goofy on that? 5 pi thirds, I'm sorry, no, it's bigger than 4.5 over, yeah. Okay, so as I'm looking at this then, well, quadrant 4. Okay, I'll make that note. Do we have a way to find theta prime in quadrant 4? I think so. So what I'm going to do is I'm going to do way more writing than you would probably normally do. But let's just check. Theta prime is equal to, how do you find it? It's in quadrant 4. Do you minus 2 pi or is it 2 pi minus that? 2 pi minus this. So this is 6 pi thirds minus 5 pi thirds. And what is theta prime? Pi thirds. Okay. Now, we have this weird, and I don't necessarily want to say it's just weird, but it is kind of roundabout. Here's what I'm thinking. I know at this point that if I wanted to evaluate this, and this statement's the big one that you may not always write, but I want us to write it right now. What we have just found out is that the sine of 5 pi thirds is very similar to the sine of this reference angle. Here's all that we have to worry about. In quadrant 4, dealing with sine, should it be negative or positive? In quadrant 4, the y values, or the signs, are negative, right? So I have to make note of that, evaluate it using theta prime. Here's my original. This is the exact same thing as, I'm going to leave a little awkward space right in front of it, the sine of pi thirds. But what did we just say I had to be mindful of? It's a negative because it came from quadrant 4. Now, again, it's not lost on me that this seems maybe unnecessarily convoluted, but it only feels that way because we're thinking about it from nice angles. If I didn't know the whole unit circle, which right now we haven't, I'm not going to like surprise you with it. Anybody feel like you would get 100% in your unit circle quiz right this second? I think I would. I'm pretty sure I would. I think a lot of you probably would. No shade, but like realistically, it's new and kind of ugly. If you don't have the whole unit circle memorized, do you think you could at least do quadrant 1? Like, if you can't do the whole thing, you can probably do quadrant 1, or at least bits and pieces of it, which means if I don't want to have to memorize the whole thing, where does pi thirds live? Quadrant 1. If we have just quadrant 1, which we need to memorize the whole thing anyway, we can just evaluate this from quadrant 1, and it's easy. Pi thirds, and I'm going to sketch this out. You do not have to, but I'm just trying to do it without looking at a unit circle. Pi thirds, is it up high or down low? High, so it's right here. Now, in my head is where I think about this, but not everybody can think about it like that. What is the sine at this point? Root 3 over 2. I know the sine of pi thirds is root 3 over 2. And we just found out that this wasn't just the sine of pi thirds, it was negative the sine of pi thirds, which was negative root 3 over 2. And looks like we're done. The sine of 5 pi thirds, only using this reference angle and not having to look at everything else, is just negative root 3 over 2. If you check your unit circle, and we find 5 pi thirds, and I'm just going to go to the unit circle. Is it in the front of the book? I don't know. Looks like it. If I go all the way to 5 pi thirds just to verify this, and where's my, there it is. 5 pi thirds is down at the bottom. Is it negative root 3 over 2? And without ever having to have the whole unit circle, just quadrant 1, we'll get this. Okay, I don't think we need 6 of these. I'm going to be honest. If we do, we'll get 6 of them. I want one more, though. At least one more, and then we'll just kind of see how it goes. And I just lost on my notes, but that's all right. So, one more of this type, and I just want to see what we come up with. I want you guys to help me find, using reference angles, we'll call this example B. I'm going to put this back up just in case you want to use this as an example. Bravo, and I'll let you guys try this one. I want you to do the following. I want the, do you want a tangent or a cosecant? Cosecant, deal. I want the cosecant of 11 pi fourths. 11, I'm going to make that very clearly, say 11 pi fourths. I'm going to fix it because I hate it. I don't know why I hate it. 11 pi over 4. Now, there's a couple weird things about this, but I'm going to let you figure it out. I'm going to give us like 90 seconds of me wandering around, just kind of listening and looking over your shoulders to see what's happening, and then we'll come back together and discuss. Cool, cool, cool. Talk it out. Use your collective knowledge. You're all capable of doing this. You might not feel like it right now, but everybody here can do this problem. I'm sure of it. Let's try. Get really loud. Because I put some things on here that I normally don't write, but I didn't know how far we went. So a couple things. Are we okay with theta prime being pi fourths? Okay. Now, here's what I'm thinking, and I'm going to cover this up for just a moment, and if you're watching the video, you can't do it. When I started, 11 pi fourths is in quadrant 2, right? I'm using a quadrant 1 angle, though. Like, that's a reference angle. I'm thinking of that little acute angle. If I'm in quadrant 2, cosecant can be hard to think about, like whether cosecant is positive or negative. But cosecant is a reciprocal of what? So in quadrant 2, is sine positive or sine negative? In quadrant 2, sine is positive, right? It's a y value. If sine is positive, its reciprocal is also positive. And what's the reciprocal? Cosecant. So this statement, that's me. I know we're doing cosecant, but because I think about sines instead because they're easier, I run through and say, well, sines are positive, so cosecants are positive. It means that I know that when I use this reference angle, it's going to be a positive number. If this had been, a quadrant 3, in quadrant 3, sines are negative, so the cosecant would have been negative. That's the logic that I'm putting together here. Now, once we get it, realistically, I don't know that it's, again, and Christina, I think, is who I agree with on this. She said, I think this is a waste of time. And sometimes it is, legitimately. But we need approaches that we can use for when it's not a waste of time, and it's easier to get practice when it is easy. So, looking at this, we have some choices. I now know that I just need to simply evaluate, instead of the cosecant of 11 pi fourths, it's the same as me just evaluating what? Pi fourths. And now it's decision time again, some more, because you don't have cosecants listed anywhere in your unit circles. There's a couple ways you can think about this. You can think about it as being 1 over the sine of pi fourths. Right, that works. And this is worth noting, and I'm going to make a comment here. Let me do this. Before I make this comment, everybody okay with saying that's the same thing? Which identities are we using? The reciprocal. We should have it right away, but doubted ourselves. Don't doubt yourself. Okay. Alternatively, this right here is just the reciprocal of sine. That's how we write it. when I were to actually do this, I would just find the sine and I would just flip it after the fact. But this works all the same. What is the sine of pi fourths? Love it. So this is 1 over root 2 over 2. And all of a sudden, exactly what I'm doing in algebra 2 right now. How do I fix this? Not times 0. Times 2. Without changing it. What do you mean times 2? Just to encourage you a little bit, I know exactly what you mean, but I want you to say exactly what you mean. If I start it, you'll be able to finish it. Multiply by the reciprocal. Like, that's what you're wanting me to do. So I will do that. Instead of dividing by this mess, and there's a couple ways we can think about it. I view this as 1 times 2 over root 2. Don't know that that's how everybody thinks about it. It is how you think about it? Could I think about it as 1 over root 2 divided by 2 instead? Do I get the same answer? Okay, it's the same answer. I'm cool with that. So, what do we get when we clean it up? Just root 2. And we're done. Now, I do want to stress that I don't necessarily think this is always the easiest way to go. But again, there will be value in this. And if you're specified that you have to do it, then we should probably do it. But let's use this exact idea in a different situation. Okay, we have one more example, and then the rest of the time is going to be yours, just so you know. Cool. So, last one. Do you want a quick brain break? Too bad. Just kidding. What's a cleft palate?
It's one.
Vocab is winding up so much more interesting than I thought it was going to, just for the record. I thought it was going to be dry and terrible and boring. Krina, sorry I didn't even try to beat you today. Tomorrow, I got you. All right, here we go. We're going to let theta be in quadrant 3. Now, I'm being very wordy with this. Your textbook will, but just so you know, on a quiz or a test, I think it's fair game if I just say this. Nope, that's the wrong cue, sorry. I think it's fair to think that you guys can do this, because we use it fairly often. You might disagree, and realistically, I'll probably just write it every time, but I want you to be comfortable with that. Okay, so theta's in quadrant 3. And additionally, we're told that the sine of theta is equal to negative 4/5. What I want us to do is I want us to find secant theta. Now, I'm going to add one more thing. I'm going to say using, and I don't think we've used this shorthand yet, but I want you to help me work it out. If I say using ID, I definitely do not mean your driver's license. Identities, right? We're going to use identities, which means we don't have to sketch a triangle with this. So, let's see if we can't put these pieces together. I'm in quadrant 2. Just kidding. I'm in quadrant 3, sorry. Sine is negative, which makes sense in quadrant 3. And I'm trying to find secant. Secant is the reciprocal of what? Cosine. So the fact that we're in quadrant 3, cosine is what? So negative in general. It will be 3/5. You are absolutely right. But it's negative. We all agree with that. So because cosine is negative, and I'm thinking about cosine because cosine. Oh my gosh. I'm thinking about cosine because we're after secant, and cosine is easier to think about. So here's what I want us to get the practice with. And again, there might be other ways. There are other ways to do this, but I want to use identities. If I can find cosine, I can get the secant. Do we agree with that? So we need a way to get to cosine then. Now, Dolan suggested using 3, and we can. There's a 3, 4, 5 trick that works here, but you might have to draw the triangle to get it. Or we could do y and r, right? We can do it that way. What I want to do is I just want to practice, because those ones are pretty natural to use. It's like good. I think everybody can do it. But I do want to try to just see if we can do a different identity as well. So instead, is there anything that relates sine and cosine together in your identities? And if you have to look at the sheet, you can. The cofunction certainly works somehow. Any others? Theta, the fact that it's in quadrant 3 makes me think it's already way above 90, so I don't know that we're going to use a complement here. An identity with sine and cosine in it. Maybe some exponents. So tangent has sine and cosine in it, but the Pythagorean identities also have it. I want you guys to have the Pythagorean identities like burnt into your brains, literally and figuratively. There's a word for this. To burn literally or figuratively. It was several days ago. Anybody remember it? One more time?
A rankle?
No, rankle is sore.
Conflagration.
Conflagration. That's what it was. Thank you. Thank you. All right. I was going to go through it. Here we go. Let's use that. Sine, I'm going to use the Pythagorean identity. And I'm only using it, just to be honest, because. Don't have another reason. Sine squared of theta. What's our sine squared theta? Plus cosine squared theta is what? Equals 1. When? Can you do that like 50 times louder? Can you still do it 50 times louder? Like, I've never heard you yell. I want to hear it.
Always?
You're counting it? My ears. Okay. Thank you, by the way. Okay. We're using this. This is always true. It's an identity. It's true for every theta. Now, can I plug something in here? What? Negative 4/5 for the sine, right? And it gets squared plus cos squared still equals 1. Now, if you didn't catch it the first time, I do want to highlight here a million ways to do it. We're using Pythagorean just because. Like, I chose it because I want you to practice with this one in particular. Well, solve this for cosine. And we'll meet back up. Or we can even go further. Solve it for cosine and then look at it for a second and solve it for secant. Cool. I will give you guys a moment. Help me out. I'm stuck. What do I do? Basil, we made eye contact. So that's okay. Thank you for your honesty. Any algebra or anything that just, like, even if it doesn't help, you're like, oh, maybe we could do this. Okay, so your next line says 16 over 25? You are correct, just so you know. Like, this is exactly what I would do on the first line, too. Okay, what are we trying to solve it for? And I want cosine so I can get secant. I need to solve this for cosine. Now, I'm going to subtract 16/25, and I'm going to skip a little bit of work. I think this is 9/25. How? 25/25 minus 16/25. Okay, can I solve for cosine now? Okay, big moment coming up here. How do I get from cosine squared to cosine? The square root. Now, I'm going to actually write it, even if you can do this in your head. But I want you to tell me, what did I forget? The plus or minus. Now, you may skip this line. And it's totally reasonable, I think, if you do. Because everybody can do the square root of this in your head, I think. What's the square root of 9? And the square root of 25? Okay, so here's the big moment right here. Root 9 is 3 over 5. Okay. How many answers did I just say we had for cos theta? But there can't be 2 answers for this cosine theta. There's only 1. How do I decide which one it is? The quadrant. We already know it's quadrant 3, which means quadrant 3 cosine is positive or negative. Get out of here. You're garbage. Can't use it. It's not the right theta. Now, once we have cosine of theta, how do we get what we're actually after? Secant. We just simply take the reciprocal. And what is the reciprocal of this? And we're done. Now, not the only way. There are faster ways out there. I do just want to stress Pythagorean stuff is going to show back up, and it's going to show back up like full swing. We need practice with it. Okay, so with the remaining 15-ish, 13-ish minutes, your assignment this evening, and sorry for the sudden left look there. Let's check. We are in 4th hour pre-calculus. And the video did not freeze today, which is pretty cool. So I'll put all the other stuff in here in just a second. But tonight, your homework is homework 4.4, which you will find on page 297. And remember what we talked about with homework stuff, right?
Yeah.
What?
You don't have to do all.
So you're right, but I'm going to word it in a way that I want it to be thought of. Don't think of it as I don't have to do them all. Think of it as I only have to do as many as needed to be good at this. Cool, which is the same statement. I trust your judgment. 15 through 25 odd. 49. 53. 61. I missed a chance here. 68, dang it. Through 71. 75 through 77. Okay. It's kind of a long assignment. Because I took a bunch of problems off of 2 different nights, just so you know. Here's kind of my thought. I hope this goes well. My thinking for tomorrow is that I would like to do a quiz.
Oh.
That's kind of my thought. Because if we have a quiz tomorrow, there's no homework over the weekend. Or, so everybody's really psyched about that. Why not? What's your other quiz? What if I just work with Dr. K to make sure that we have some chemistry and pre-calculus questions that intermix with one another? We just do one big quiz. We can write a single quiz together. We're doing a bunch of pre-calc problems using chemistry.
I'm not him, so.
That sounds like a personal problem.
What?
All right. You have 2 tomorrow already?
Three. World history.
So we should just go for the perfect trifecta.
What?
Okay. So tomorrow, we won't have a quiz tomorrow. We're gonna have a quiz Monday then, and it's gonna be weird because here's the trade-off that I'm willing to make with you. This homework, 4.4 is the mid-chapter. Tomorrow then in class, if we have to work through some of these, and I imagine we will because the homework's kind of long, we'll go through whatever we need to. But then we're gonna start 4.5, and then we're gonna quiz 4.1 through 4.4 on Monday. But we will start the next section. The good news is it will not confuse you even a little bit because tomorrow it's not even, like, it's the same stuff, it's still trig, but it's not going to get confused because we start graphing tomorrow. So bring graph paper. Cool. All right. Well, I have you guys start working now. I'm going to make the note here. This is due tomorrow, but I will go ahead and say thank you for letting me know about a bunch of quizzes in one day. Like, always be vocal. Do you tell your other teachers the same things?
Yeah, but they
You
don't.
should. They might not care.
Yeah.
That's okay. I get it. Quiz on the Monday, which is, let's see here, 24, 25, 26, 27. Cool.